A block B of weight 28 newtons is pulled at a constant speed across a rough horizontal surface by a force of magnitude 14 newtons, inclined at 30 degrees above the horizontal. Show that the coefficient of friction between the block and the surface is 0.577, correct to 3 significant figures. The 14 Newton force is suddenly removed and the block decelerates, coming to rest after travelling a further 3.2 meters. Calculate the speed of the block at the instant when the 14 Newton force was removed. So here's the picture described of the problem then. It's moving at a constant velocity, which we can label as v. First thing is to show that mu is 0.577. 14 Newton force, rough surface, so there's a frictional force here of mu r, isn't it? Mu is the coefficient of friction and r will be the reaction, the normal reaction of the weight. So let's have a look at part 1 now then. So resolving for forces vertically, F equals ma gives, there's no acceleration, so the resultant force will be 0 vertically, r plus the 14 cos of this angle, this is 60 here because this is 30, so this is 60. Cos 60 is sine 30, which is a half, so I put a half in, is equal to 28, or minus 28 equals 0 rather. Minus 28, those forces equal 0. So R is equal to, this is move the 28 over, this is 7, move this over, minus 7. 28 minus 7 is 21. So R is 21 newtons. Now horizontally, it's moving with constant velocity v, so horizontally the acceleration is 0. So apply F equals ma horizontally now then. There's no acceleration, so the resultant force is 0. So F equals ma horizontally gives, we got the 14 Newton force, cos 30, because it's inclined at 30, is root 3 over 2. So that's that force, 14 cos 30, minus mu r, minus mu times r, which is 21, got it here, is equal to 0. So that tells us then that mu, move this over, 21 mu is equal to 7 root 3, isn't it? Because one of the 2 will cancel top and bottom. And that tells us what mu is. 7 root 3 over 21. 7's cancel, so we get root 3 over 3, or 1 over root 3. Either of those will be fine. 1 divided by root 3 then. So 1 divided by the square root of 3, decimal, 0.577, which we wanted to show, and that's to 3 significant figures. So that's that answer there then. Okay, good. So we've shown mu in part 1. The 14 Newton force is removed and the block decelerates to rest after 3.2 meters. Calculate the speed of B when the 14 meter force was removed. So part 2 then. So let's apply F equals ma horizontally. Now the 14 meter force is removed. Horizontally, the mu r will still act, won't it? So it's minus mu times, now what's r? Well, we don't know r, do we? So let's just put it mu r. Minus mu r is equal to the mass, which we don't know, times the acceleration a. We know the mass, we know the weight, so we'll know the mass. Okay, there's 1. Now if we look at vertically now, because the 14 Newton force is no longer there, so the normal reaction vertically will equal the weight, 28. The normal reaction is equal to the weight because this force has been removed. So vertically we have that situation because these forces must be the same. And we've also got the weight, 28, is equal to mg. So it tells us that m is equal to 28 over g. So this is 2, this is 3. So minus 1 over root 3 times r, which is 28, equals the mass, 28 over g, times the acceleration. So 28's cancel, and the acceleration will equal, move the g up, minus g over root 3, which we can write as root 3 over 3, can't we? So there's the acceleration with a minus. So it decelerates to rest. So now we know the acceleration. We know the distance. And the block decelerates to rest after 3.2 meters. Calculate the speed of B when this force. Let's calculate the original speed. So S is equal to 3.2. U, we don't know. The V, the final speed it comes to rest, equals 0. So we've got all these components, so V squared equals U squared plus 2AS comes to mind, doesn't it? So this formula then gives 0 squared is 0. U squared, we don't know, plus 2A minus 2 of these times the distance S, which is 3.2. So put that in there. So now we can work out U. So that tells us then U is equal to, move this, all this over the other side. So it's 2g root 3 times 3.2 over the 3. So we've moved all this over there. It's u squared at the moment, so if we square root we get u. So u is equal to then. So it's square root of 2 times 9.8 times by root 3, square root 3, outside the square root, times by 3.2, divided by 3. So that's everything. Yep. Equals 6.0175, 6.02, isn't it? To 3 significant figures. Just double check that. 6.02 to 3 significant figures. And that would be meters per second.